Hello everyone, welcome to this Lattix demonstration. Today we are going to focus on security impact reports and analysis. We're going to use our standard C and C++ example, which is called ISO glib. And as is common with many C++ embedded systems, this is a simple C++ library which we can build and test and analyze within a DevOps pipeline. So here we've put together a pipeline in GitLab that builds, tests, and analyzes the software, so that if I, as a developer, now make changes to the system, I know whether I've made a breaking change, perhaps I make a change which causes a test case to fail, or I've introduced a security vulnerability, or I've introduced a compliance violation, such as a requirements issue, or lack of traceability, for example, or some other issue which I, as a developer, have caused by injecting a change and bringing that change into a branch. So here we have a working pipeline. We build the software, we analyze the requirements for the system, which in this case is implemented in the Jammer tool. We also then do some unit and integration level testing with the Parasoft tool suite, and also coverage analysis is performed at this level. Then we use the Parasoft taxonomies or groups of checkers to perform a security analysis with respect to the CERT group of checkers, the CWE framework, and the OWASP top 10 vulnerabilities listing. Once we've done the security analysis, we also do an architectural analysis using Lattix, checking, for example, that we have obeyed our architectural rules at API, layering rules level, or independent subsystem rules. And then we produce the documentation, for example, for compliance, for heat maps to visualize the issues across the architecture, for traceability to find any traceability gaps, or any other violations such as metrics. But today's focus will be the Lattix security impact report. Once Parasoft has identified security vulnerabilities, how then can we assess the impact of those security vulnerabilities across our system? And that's what we're going to be focusing on today. So once we have a pipeline building end to end, I'm now going to inject some new code into this ISO glib application, and we will see what Lattix can do with the identified security vulnerabilities. So firstly, I'm going to go to VSCode. Let me just jump to the IDE. Here we go. And within the util-funcs.cpp, this is contained within the util layer of the ISO glib application. I have a function called getCStringCount. And here in this function, I am going to hard code a couple of strings, one called uname for the username, and I'm going to hard code that to admin. And I'm also going to hard code a password called change_me. And then you can see that I'm passing these credentials to a function called getData. And this is a very common mistake that developers make when they are building in security. They would maybe just have a local something I intend to change later kind of username and password. And then sometimes, often in some cases, we forget to make those changes to the hard-coded passwords, and we leave them in the system. And this is a known vulnerability. In fact, if you look at the Parasoft report that gets generated on this code, and if I just search for the change_me string in this case, I can see that these four checkers or checker results here that Parasoft has identified, it has indeed identified not only have I hard-coded the strings, admin and username, also I've hard-coded credentials, the change_me password, and you can see on this side which particular rule that violates. So we have violations of the MSC 41 rule within the CERT standard, and the STRA30 rule also within the CERT-C standard. And you can read more about MSC 41 and STRA30 in various open source wikis and documentation sources, such as the SEI from Carnegie Mellon University, which then explains why you should not attempt to modify string literals this is a violation of STR30. And for MSC 41, we should never hard code sensitive information such as passwords or encryption keys, because anyone who has access to the executable or the dynamic library files can examine them for those strings and thus reveal the sensitive information. So here we have these two vulnerabilities. They are in my code base, and Powersoft has identified where they are in my report. So let's look at Lattix firstly, and we can see this function that we've been using and working with. GetC string count has, we can actually identify the first level of impact visually, because we can see, if we look at the usage of this function, we can see that this function is used up in the COM layer through a function invocation to part 12 diagnostic services. So we can see that there is a function invocation within diagnostic pgn handler underscore c.cpp within part 12 that uses this function getC string count. So already we're aware of some impact, but Lattix can calculate the complete impact of a vulnerability. And we call this transitive closure, where there is a first level of impact that we can see here, but there are subsequent levels, because what happens with this function that calls our getC string count, and what happens to the function that calls that. And so we get a chain of function calls that we want to see as the impact progresses through our system. We can also see in this function there is a relationship to the requirements domain. In this case, using Jammer, you can see that this function satisfies the requirement 131, that data shall be accessible only via username and password in a secure strings vault. And we can see that this particular requirement is satisfied by the getC string count function. So we also now know that this vulnerability will impact not just the code domain, but also the requirements domain as well. So firstly, let me calculate that impact of the vulnerabilities. And you can see on the left here that automatically Lattix has imported the defect data from Powersoft and the security vulnerability information, and created tags for those vulnerabilities, so that we can see there is a tag for the MSC41 and a tag for the STR30 vulnerability. We can now perform a complete impact analysis of those vulnerabilities with respect to the architecture, just by running an impact report. And I'm going to select MSC41 as the first tag to run the impact analysis on. I do want the analysis to transitive closure, so that it will include the indirect dependencies in the report. And I also want to show member level to see which functions and methods are being used in this impact analysis. So once I've set this up, I can now run the report, and you can see there are 8 levels of impact that are created by the security vulnerability. And 26% of my entire system is potentially vulnerable and exposed to this particular vulnerability. So let's look at the first level of impact. And you can see here that our first level of impact, you see getC string count is used by part 12 of the COM layer, as we visually inspected in the dependency structure matrix. And we also see the impact on the satisfied by requirements relationship, because this particular function implements a requirement 131 in this case. But what about these subsystems used by these systems? What about these two subsystems? How do they propagate that impact? Well, we can see, if we go to the next level, that this part 12 diagnostic services, diagnostic PNG handler underscore c.cpp, has a direct invocation by part 5 of the network management of the COM layer. So if we go back to the DSM, we can see the impact is now going from our util layer, it's going up into COM, it goes from part 12, and now it goes to part 5. So it's crossing multiple trust boundaries as this impact propagates, as the impact of this vulnerability propagates. So there are 8 further levels of impact. We will just look at one more. We've seen the impact on part 5. Part 5, we can also see it now jumps to part 10, and part 5 jump into part 5 again. Within part 5, there are further, it's causing further impact within the scope of part 5. Okay, let's see how this looks now in the Impact Explorer in VS Code, because we can actually explore the impact of this security vulnerability in the comfort of our integrated development environment, our IDE, which in this case is VS Code. And you can see on the right-hand side here, there is something called the Lattix Impact Explorer. I'm going to select the file util.functs.cpp, and you can see that the data that I need to assess this vulnerability is now conveniently provided in the Lattix Impact Explorer. And you can see, firstly, that the function here gets the string count is in the util functs, and we have the invocation here in via this getC string count function within line 488 of the diagnostic CPG handler underscore c.cpp. That's what we saw in the dependency structure matrix. And we can see this function call is then happening within the set SW identification function. What's the next level of impact? Well, all I need to do is open up the upstream used by report here, and I can see the next level of invocation as to where set SW identification is now being called. And you can see line 321, this function here of ident item underscore c.cpp is now being called at this location. And so on, I can traverse the impact all the way through now from part 12 through to part 5, and then through to part 6, and so on, until I explore the complete impact of this particular security vulnerability on my system. And as you can see here, it has created a significant amount of impact. Maybe a quarter of our system is affected by a vulnerability in this getC string count function. If I now go back up to the highest level of my impact, you can see towards the bottom here we have the requirements domain data also now being brought into VS Code. And you can see that our satisfied by relationship requirement 131, which says that data stored in secure strings vault shall be accessible only via username and password. This too is affected by this particular vulnerability. So our vulnerability has impacted not only our source code, but also our requirements domain. So that concludes our short demonstration of the Lattix Security Impact Report. Thank you for listening. And if you have any questions, please do not hesitate to get in touch. Thank you.